Hello and welcome everyone to another video for records, and that video we will learn about the enjoining material and deep processes. So let's start with the first light. We have in more detail on the right side, you can see their classification and declassification. We have those sorts of materials were not metallic, but they are non-metallic and metallic. Further, we have ferrous non-ferrous, so then we have plain alloy gray by the cost data. Aluminum, copper, magnesium. In case of non-metallic material we have organic, plastic, paper, rubber, and in the organic we have a mineral, semen, glass that make an extra. Actually, as a mechanical design engineer, you shouldn't need to learn about the engineering material. There are structures that basic chemistry and geometrical, so engineering modules are also depends upon your industry. So like if you are in sheet metal industry, you mostly use the steel, aluminium. If you are in casting industry, you will use their lives. So all these and the limitations of it is according to the industry worth, so you need to learn them according to the requirement of your industry. Then we have the chemistry of materials. You can see the chemistry when is crystalline and as amorphous in the crystals, and we have less molecular spaces and the molecules are loosely bonded and closely tied in the more floors. You can see there is a huge distances and the molecules are very wide and far from each other. So on the base of dark we can see we have grassland sorted. We have the example of dark there that is very hard, very brittle, very hard to break it, known as crystalline. Slaughtered. All these are an example of that. In case of amorphous, we have sand that is displayed very easily with a little forward. These kinds of green structures form biological tissues, so we can differentiate on material on the basis of a more pleasant crystalline, slaughtered on the basis of their chemistry. Another important topic is grain stocks. Did actually in any material or any part is going to subjected any sort of load or any mechanical process, a good instructor is changed. So grain structure change means we are losing our properties like hardness, brittleness, decorative, malleability, changes of a degree instructed. So in order to maintain them as a requirement, we need to select our machining process according to the requirement good instructed. Here you can see the grassroots attending the growing process. You can see here now the green structures are loosely backed as compared to dark fields, so every machining process is going to fit the green structure. So we need to select them according to a requirement, which kinds of properties we need to maintain their property. We need to change the machining process, so green structure is a very important topic, and we would go discuss in a specialized material causes. So let's start with some test. Must we have spectroscopy? You can see that this test is used for the identification of lies and the chemical stuff it in dark, the radiations it falls on the surface of that particular specimen object, and then we have these back radiation. And these radiation which are deflected from our specimen gives these kinds of spectra. And by studying that spectrum we will give the correct chemical composition of the object. This test is widely used for that indication of Beloit. This is also used in the reverse engineer process. Actually this test is based on the principle is dark, then there is specific frequency followed on the surface of the metal. They didn't read these kinds of spectra and all the metal to have their different sorts of spectra. And by studying that spectrum we can get the exact amount of the metals also. These are done another test used for measuring the properties of the object like. Plus we have a large city plasticity, a little bit less toughness, malleability, art. So 10 scientists perform blind elasticity, plasticity and the totality of an object. Then we have to be desktop. It is used to detect the brittleness, malleability, impact, load and toughness. Open specimen. Then we have Rockwell test, which is used for hardness. On the other side we have another test. It is also used to check the hardness open object. Then we have U-beam universal testing machine, which is used for comparison, compression, Lord, dear Lord and say law, breaking, strand and spring failure. These are the doors in which began to discover specimen, and we can measure the compression, the tension. Here we need, in case of shear, Lord, we need some sort of days and guess a break spend. We also need some sort of lesser LE specialized fixture, so in case of spring value we can use these jaws and begin to destroy a spring here, and we can measure the strength of the spring. This is the important parts. Vestry and go is used to define the strand of the material according to the ideal specimen, called no specialized schools, where we discuss them in detail. Actually it's a very necessity by selecting a material for the specialized used. Machining processes. On the left side we have the detail of machining processes like turning process, shipping, planning, drilling, billing, writing, etc. On the right side you can see all the operation performed, understanding processes that we have facing a battalion, conquering, form, dummy, jam, frame, grooving, threading, boarding, drilling. Nearly all these 4 operations can be performed on lathe, and this is known as dumbing process. Then we have shipping process, in which our piece of a job is stationary and our tool is moving, and we can perform these kinds of operations. In the planning process our job is moving and pieces of a tool is stationary, so we can perform these sorts of operation on blending process. So in the drilling we have drilling, ramming, boring, control board, boring, compressing and tapping. Then we have grinding. You can see here surface grinding, foam grinding, landing gear grinding, into metal grinding. Again we have milling. You can see the milling, this milling inside a million, angler milling, gang milling, or milling. All these processes as a tool to select according to the requirement of the instructor. Sometimes some sorts of piece need specialized machining process, so we've discussed above them a number of specialized called it. You can see the drying process, in which we insert our work from one side and the in between the day. This is the actions of motion, and then we will get our desired slides. Let's suppose we are reducing their day off in gears of war making machine. This is processes, get it out. So one side here the light of a larger dive in theater, and the other side of it we get the exact day. We want this is an honors extrusion process. Next we have heat treatment processes actually. Then we have machining processes that do machining processes. There is a lot of stresses induced in no object. So in order to remove that stresses and increase the properties like hardness, temper, then bring and all of the properties, we are performing heat treatment processes. So these are the list of some of the equipment processes like hardening, tempering and link opening. Actually, these are very important topic by selecting a machining process and then further improving its qualities and properties. So we will discuss them, and in a number of specialized schools this is a wordy diagram known as time, temperature transformation diagram on foot fetish routine. It is a very important topic. Gasol, a great man. Again we better discuss them in number of specialized schools. Thanks everyone.